In this video I'm going to show you how to work out the prime factors of any number. You may need to do this if you're going on later to work out the highest common factor or the lowest common multiple of any number. But before you do, you'll need also to understand the concept of what a factor is and what prime numbers are. So if you need a refresher on those, there are videos down here. I'll also do a video of explaining examples after I've shown you how to do it. Now, firstly, an important point. Whichever method you use, I'm going to show you a couple, and there may well be others, but whichever method you use to find the prime factors of any given number, you should end up with the same answer. There is only one set of prime factors for any given number. So it doesn't matter which method you prefer, and I have had people concerned that one method may not give them actually as good a set of answers as another. The answers will be the same. So the first thing I'm going to show you is a method which is known as the factor tree method. It's the same as any other method, but that's what it's known as, and it's probably the easiest one to approach, the most accessible one if you haven't done this before. I'm going to be a little brave, or some might say foolish, in generating random numbers that we're going to try. To do that, I've rushed out and mugged a 12-year-old and got their microbit. Well, not exactly, but you know what I mean. And I've programmed this, so I'm a bit of a geek, to give me random numbers. I don't know if you can see, but at the moment it's showing me a 7. If I give it a quick shake, didn't respond, it's giving me a 3. So on shake, it will give me a different number. We've had a 7 and a 3. Good enough as any, so I'll use 73 as my first number. Okay, let's try 73. You'll notice also that I've written the prime numbers up to 100 at the top of the board, so we can refer to those if we need to check. Okay, so 73. The first thing we need to do is, are there any factors of 73, or is it a prime number? Because if it's a prime number to start with, you're on a non-starter and you can't do it. Quick check, it's a prime number. So that one is a no-go. So we'll rub that one off. And we'll start again. Always worth checking if you're generating your own examples, because prime numbers obviously don't do anything. Here we go again. 9, 2. 92 is definitely not a prime number. So 92. Factors of 92. What goes into 92? Is there anything you can think of in particular that goes into 92? Well, apart from 2, which is quite obvious, we'll try that. We'll try doing it by 2. So we've got 2 here, and we've got 46 over there. 2 46s are 92. Now, whenever you come across a prime number as a factor on this, you have to indicate that by putting, I would suggest putting a circle around it. So I'll put a circle around the 2, because 2 is a prime number. That will be one of our prime factors. 46, what does that divide by? It's 2 23s, isn't it? So let's do that. 2 times 23. Now, 2, as we know, is a prime number, so that will be another one of the prime factors. 23, now there's that. Aha, 23 is also a prime number, so there we have our prime factors. We can split this no further. None of these numbers can be split up. So our answers for this one are 2 times 2 times 23. You might occasionally have to express that as 2 squared times 23. Same thing. Okay, let's have a look. Another one. Let's get the old micro bit. Shaking. 4, 6. I won't do 46, we've already had 46 there. Let's try again. Shall we use the 6? 7. 67 is already a prime number. Try again. We had a 7 and an 8. Let's use 78. Okay, 78 is not a prime number. I have 78 over here. Okay, so what does 78 divide by? Well, it divides by 3. It divides by, I think, 13. So let's divide 78 by 2 to start with, shall we? Because that's quite easy. 2 and 2 39s are 78. Okay, 2 is already a prime number, so that must be one of our prime factors. Circle that one. 39 is not a prime number because it happens to be 3 times 13. Now 3 is a prime number, 13 is a prime number. So in this case, these are our prime factors as well. So our prime factors of 78 will be 2 times 3 times 13. We can't split any of those numbers down any further. So it's just a case of splitting your number into factors and then splitting each of those into factors and keeping on going until you can't split any further, and the numbers you end up with will be your prime factors. It could go on a bit further than that. I'll be brave over here and try a 3-digit one and see what happens. Let's see if the micro bit gets its revenge on me this time. I've got a 1, a 1, and a 4. Okay, we'll try 114. Well, yeah, this could be, well, it's not that quick. Let's divide it into 2 to start with. So twice 57 is 114. I was a bit concerned a moment that 57 could be a prime number, but it isn't. So we've got 2, which is a prime number, that will be a prime factor, and we've got 57. That happens to be divisible by 3, doesn't it? So, wrong colour chalk. So if we divide that by 3, we get 3, and we get 19. 3 19s make 57. 3 is a prime number, 19 is a prime number. So that also was a reasonably quick one. Now, you can end up with these things when you're doing these factor trees with quite a large number of blobs all over the page, and you have to recognise where the prime numbers are and write them in. Then you have to put them into order. Mine have tended to be into order because when I do it, I tend to start with the smallest numbers when I'm dividing. I don't tend to think of completely random factors. I think it's easier that way. So there is another way of doing this which sets it out, I think, a little more clearly perhaps. You don't have to search the thing thinking, oh, what have I got? Oh, I've got 2 times 3 times 19. And it's called the division method, and I've heard it called the ladder method because it looks a bit like a ladder. So I'll try that over here to show you this one. In case you prefer a slightly more logical, I think, approach, I will use initially the same number. So I'll do 114 again, so you can see, you can compare the two. So I'll start again with 114. Now this time what I'm going to do is divide it by prime numbers starting with the first prime number, which is 2. So I do this and I put a 2 in there. 2's into 114, as we know, a 57. Then I do that again and I think, okay, can I do 2's into 57? No, I can't. So I can't do 2, so I look at the next number. Do 3's go into 57? Yes, they do. 3 19s. Then I do this and I think, what goes into 19? Nothing except 19. So 19 itself goes into 19. And 1 is the answer. Now 1 is not a prime number, as we know. So this one I can read straight down here in order, and the answer will be 2 times 3 times 19. Okay. Going to do one more that way over here. I'll do a 3-digit one, which I'll get my trusty micro bit, if it's still working, it is, to do for me. Okay, I've got a 2. Yep. I've got a 9. And I've got an 8. Okay, 298. So the first thing I do is think, can I divide 298 by 2? Because I work my way along these here. This is a bit of a mental arithmetic challenge here. Okay, so can I put 2's into 298? Yes, it works, doesn't it? Obviously. It's 149. Okay, then I say, can I put 2's into 149? Just checking my list of prime numbers up to 1,000 here to make sure that 149 isn't actually on there, because that would be embarrassing. It is! What luck! So as it happens, 149 is a prime number. So therefore, for that one, all we can do is 2 times 149, and we've got 2 times 149 as my slightly unexpected answer. Right, I better try one more of those. It's a joy of doing it on the fly with a micro bit, isn't it? Right, what have we got? 7. Wow, it's going to be a big number if I do 3 digits, isn't it? 7. Could take a while. 1. Another 1. It's going to be, insist on being 1, wasn't it? But right. We can do our usual with this one. Obviously it doesn't divide by 2 because it is in fact an odd number. The digits 7, 1, 1 add up to 9, therefore it does divide by 3. So I can put a 3 here. It divides by 3. It divides by 3 237 times. I'll have to check this later. I think so. Okay, that one doesn't divide by 2. But again, 7, 8, 10, 11, 12, it does divide by 3, so I can put 3 here. 237 does divide by 3. It will be 79. Okay. 79 is on my prime list. Okay. So I get 3 times 79 for that particular rather splendid number there. Okay. I'm now going to rub all of those off and put some examples down here for you to try, which I will then go over in a subsequent video, which will be the next one, somewhere down here. Right, so I've rubbed off all that and put up some examples here. Now, I dare say you can follow through this when I'm doing it, and follow me and see what's going on, and we can get there. What you need to be able to do is get there on your own without following me. So, I want you to find a piece of paper and a pencil, have a go at these, and then look at the next video, which is down there, and watch me go through them to see if you've got them right. Okay, so now's the time to pause this just before the end and write those down.